the Lyman series of the hydrogen spectrum can be represented by the equation frequency is equal to 3.2881 into 10 to the power 15 second inverse 1 by 1 square minus 1 by n square. The question here is the maximum frequency of the helium spectrum in this series is. How we will find out? Now students, remember one thing, that I told you in my previous session also. When the electron is coming from infinity to any level, it may be 1, 2, 3, or it may be, let's take up 1. What happens? Maximum energy is released. Right? Now when maximum energy is released, what will be the frequency of light? The frequency will be also maximum. Right? What would be the wavelength? Wavelength would be minimum. Why? Because frequency is inversely proportional to wavelength. Now when the electron moves from, say, second energy level to the first energy level, what happens? There is very less difference between, or the difference in energies between these two levels is minimum. Right? So what will be the wavelength of the light emitted? The wavelength of light emitted would be maximum. Right? Now let's solve this question. What is asked here? Maximum frequency. So what is the value of N2? N2 will be equal to infinity. Right? Now let's take up the calculation over here. Let's take up here. Okay. Maximum frequency is asked, right? Now what was your equation given? The equation given is nu is equal to 3.2881 into 10 to the power 15. That is 3.2881 into 10 to the power 15 second inverse, and it is 1 upon 1 square minus 1 upon n square. Now we have to find out the maximum frequency emitted. For the maximum frequency emitted, N2 is equal to infinity. I explained you just now. Now for which atom it is? It is for helium. Okay. So for helium, what is your this thing? Isn't it for helium? This is for helium, right? So there is nu should be equal to 3.2881 into 10 to the power 15 multiplied by z square. Okay, and this will be multiplied by 1 by 1, right? Or nu will be equal to 3.2881 into 10 to the power 15 multiplied by, what's the atomic number of helium, students? It is 2, right? So the atomic number is 2, so it should come out to be 2 square or 4, right? So that is multiplied by 4. And what are we going to get here? Let's calculate this. It is 3.2881 multiplied by 4. So what are we getting here? It is 13.1524 multiplied by 10 to the power 15. Wasn't it a very simple question? It is actually. So what can I do here is, this is our answer. Let's see if there is any option matching. 15, right? And this would be hertz. Okay, so what was our option? We can write it as, it was 13.1 into 10 to the power 15. Can I write it as this? 1.31 into 10 to the power 16 step per second. Per second is hertz, right? So this is your answer. Now students, it is a very basic and it was very simple question. The only thing you need to remember is where the energy emitted is maximum and where the energy emitted is minimum. That's it. The relationship between energy and the wavelengths. The questions which come from the structure of atom are very simple. They are simple, tricky questions. They are not very difficult ones. They are simple two-liner questions. That's it. Let's take up the next one over here. Yeah. It is maximum wave number of lithium the option was wrong. Maximum wave number of lithium ion spectrum in Balmer series is approximately. The maximum wave number. What is the relationship between, we found the maximum frequency, right? So your frequency is inversely proportional to the wavelength, or we can say the frequency is directly proportional to the wave number. Now from where we are getting maximum wave, maximum frequency? When electron maximum frequency, when it is emitted, when the electron moves from or goes back from n is equal to infinity to n is equal to, now what is the series? If it's Lyman, it should be infinity to 1. If it's Balmer, it should be infinity to 2. Right? So the maximum wave number, where from where we can obtain? That is again 1 by lambda is equal to 1.906. That is the Rydberg's constant multiplied by 10 to the power 7 meters multiplied by 1 upon where the electron is coming to the second energy level. From where it is coming? From infinity. Got my point? Now students, there is Z also. Into the Z square is also there because it's not hydrogen. Okay. So this value is for hydrogen. Now what can I write here is 1.9067 multiplied by 10 to the power 7 multiplied by Z square multiplied by 1 by 4. Now what is Z for lithium, students? Z for lithium is 3. So what can I get here? I'll get here 1 by lambda is equal to 1.9067 multiplied by 10 to the power 7 multiplied by 3 square, and it is, students, divided by 4. Right? So this is divided by 4 and now it is equal to, what will be the value equal to? It comes out to be 4.2 into 10 to the power 7. Okay, and that should be meter inverse. That's why I corrected this option. It was, none of the options was correct. So this is the way how we find out. So students, had it been maximum wavelength, what we would have done? Let's take up this question over here. It is, this was question number 5, I suppose. What was it? Yeah, it was one of the passage. Let's take up one more question here. What is the wavelength of the longest wave in Balmer series? Now what we would have done, when is the longest, the wavelength is inversely proportional to energy, or the it is inversely proportional to frequency, and frequency is directly proportional to energy, right? We can say here that your wavelength is inversely proportional to frequency of light, and this frequency is directly proportional to energy. Okay, so when will the longest wave be emitted? When the energy emitted is least. That is, when the energy difference between the two energy levels is the least. So it should be N1 is equal to 2 and N2 should be equal to 3. That is the shortest, right? The minimum difference in the energies. Okay. Now let's solve this here. How can we do? 1 by lambda is equal to 1.0967 into 10 to the power 7 multiplied by, it was for helium, right? So helium ion, I'm so sorry for that. So multiplied by, it would be 2 square, we'll take it for helium, that question was for lithium. We can make it 2 square into 1 upon 2 square minus 1 by 3 square. So what are we going to get? 1 by lambda is equal to 1.0967 into 10 to the power 7 multiplied by 4, and let's solve this. It would be 9 minus 4 upon how much? 4 multiplied by 9. That gives you 5 by 36, right? So how are we going to solve this? I think you know this much of maths. Okay, so 1 by lambda is equal to 1.0967 multiplied by 10 to the power 7 multiplied by 4 multiplied by 5, and that is divided by 36. Right? Now let's divide this. So it is 1.0967 into 10 to the power 7 into 4 into 5, and that is divided by 36, right? Now it comes out to be 6.09 into 10 to the power 6, right? Now we have to find out what? We have to find out the wavelength. And that will be 1.6, that is lambda is equal to 1.64 into 10 to the power minus 8. meters. Clear? So, this is the thing we do. Now 1 point. So this was just an example.
Now
for
let's
you,
take up
right?
our next question.
So the wavelength of the light emitted would be 1.64 into 10 to the power minus 8 meters.